Hi everyone. So this week we're going to go over some of the technical concepts that underlie the nature of arguments. And we're going to begin with the distinction between inductive arguments versus deductive arguments. And the difference between those two types of arguments is the way in which they support the conclusion. So in the case of a deductive argument, the idea is for the premises to guarantee the conclusion. But in the case of an inductive argument, the idea is for the conclusion to say something new relative to the premises. And this is now, when it comes to arguments, they fall into one of these two categories. An argument is either a deductive argument or an inductive argument. And they differ by the way in which the premises support the conclusion. In a deductive argument, the idea is for the premises to guarantee the conclusion. Whereas in an inductive argument, the idea is completely different. The purpose or the aim is completely different. The idea, rather, is for the conclusion to give you more information or generate more knowledge, K representing knowledge, on the basis of the premises. So the two kinds of arguments are trying to do very different things. In the case of a deductive argument, the idea is to show you that the conclusion is contained in the premises. Whereas in an inductive argument, the idea is for the conclusion to give you certain information that is made plausible by the premises. As the lecture notes go on to say, one type of argument isn't better than another. It's really a function of what you want to accomplish, kind of like the difference between a screwdriver and a hammer. Depending on what you need or what you need to do, one tool is going to be more useful than the other. And that's just basically what these are. These are different argumentative tools. So I want to then go on to explain a little bit more about deductive arguments and in particular cover some of the concepts that apply to deductive arguments to determine the good deductive arguments and to analyze what makes a deductive argument good or not so good. Okay, so there are two kinds of arguments, deductive arguments and inductive arguments, and we know that they aim to do two very different things. One is to demonstrate that the conclusion's already implicit in the premises. That's what's going on with a deductive argument. And the other is to try to generate new knowledge on the basis of the premises. That's what's going on in the case of an inductive argument. For both kinds of arguments, there are technical concepts that apply to both kinds that we're going to use to evaluate how good each of the arguments are. We're going to start with deductive arguments, and the concepts that are important for deductive arguments are the concepts of validity and soundness. The definition of validity that's given here is a fairly technical definition, and I'm going to stay away from that definition because a lot of people seem to have trouble with it. So I'm going to try to make it as intuitive as possible. The idea behind validity is the idea of whether the premises give the conclusion logical support, whether the conclusion follows from the premises. That's basically what validity is about. Soundness, on the other hand, is where you have not only validity, but you also happen to have all true premises. So both of these concepts, validity and soundness, presuppose a distinction between the structure of an argument and the truth of the premises. So, validity is a concept that applies only to the structure. And in these two examples, we have an argument that has good structure, it's valid, and in a different argument, we have an argument that doesn't have that kind of structure, the structure where the conclusion follows, or the structure where the premises give logical support. So in the first example, the premises state, if you ate an apple, then you ate a fruit, and let's suppose that you didn't eat any fruit. On the basis of just these two statements alone, this would follow. But notice that in the other example, the premises which state, you love junk food, it's the day after Halloween, you didn't eat an apple, even though maybe it might be reasonable for you to conclude that you didn't have an apple given these two premises, it certainly doesn't logically follow that you didn't eat an apple. In other words, the premises don't logically support or guarantee the conclusion. And that's really the difference between a valid argument on the one hand and an invalid argument on the other. And we have illustrations of certain valid argument forms in the next several pages of our common inductive argument forms include what's called modus ponens. And this here, this formula, packs in a lot of information. And it's basically to illustrate that any argument of this structure, in other words, if P, or if so-and-so, then such and such. So if the car is the shade of scarlet, then it's red. That's the first premise. And the second premise, it's confirmed that the car is scarlet. These two premises guarantee that the car is red. So this is a valid argument form, and it's somewhat similar to this other argument form, but in this case, in this other argument form, the conclusion doesn't follow from the premises. So in this case, what you have is a statement of the form, if such and such, then so and so. So if the car is scarlet, then it is red. It's exactly the same as in the example above. The second premise is that the car is red. So we have an agreement here with the Q part of the formula. But on the basis of that, it certainly doesn't follow that the car is scarlet, because it could certainly be a different shade of red. So whereas this one here illustrates how the conclusion follows from the premises, and this one does not, the second is an illustration of an invalid argument. And on this following page of the lecture notes, we have several different types of argument forms that are valid. This is called modus tollens, which is different from modus ponens. Modus ponens is an argument that says if such and such, then so and so, and you have a perfect agreement with the P. And that enables you to logically conclude that Q is the case. That's modus ponens. In the case of modus tollens, on the other hand, you have if P, then Q, the same as in modus ponens, but you have an exact mismatch with the Q. And that entitles you to logically conclude not P. So to use the same statement as before, first premise, if the car is scarlet, then it's red. Second premise, let's say that the car isn't red, let's say it's blue, then it's certainly going to follow that it's not scarlet. This is going to be logically guaranteed given these two premises, and this is a valid argument. And this argument doesn't have this virtue of supporting the conclusion. This argument says, if the car is scarlet, then it's red. The car isn't scarlet, and it concludes that the car isn't red on the basis of these two premises. But this doesn't follow. Just because it's not scarlet doesn't mean that it couldn't be another shade of red, like crimson. So this is an example of an invalid argument. And what we have here are two other kinds of valid arguments. We have what's called hypothetical syllogism and disjunctive syllogism. Hypothetical syllogism is an argument that has this form: if P, then Q, if Q, then R, and then it concludes if P is the case, then R is the case. And it's illustrated with an example here. A disjunctive syllogism is where you have a disjunct. In other words, it's an either-or statement, which is what we have here. And it's where we have it illustrated by either Jane bought eggs or milk. In other words, it's the case that she bought one or the other. If we find out that she didn't buy eggs, then given this and given this would have to follow. So again, these are illustrations of valid argument forms. What's important to appreciate about the concept of validity is that it's something quite separate from the notion of the truth of the premises. So you have to really keep in mind that just because an argument is valid does not mean that all the premises are true. That's not guaranteed. In fact, just to give you an example, here's an example of a valid argument. All pigs can fly. Premise 1. Premise 2. Let's say Sophie is a pig. If it's the case that all pigs can fly and that Sophie is a pig, it would logically follow that Sophie can fly. So in this argument, we have validity, but we certainly don't have truth of premises because we know that this is false. Pigs can't fly. So this illustrates how you can have validity and not truth of premises. And you can also have a case where you have all true premises but not validity. Suppose you have an argument that goes like this. Earth is a planet. CSUN is in California, and Barack Obama is president. Now, if you look at this argument, every single thing in it is true. This is true, this is true, and this is true. But in no way do these two premises logically support that Barack Obama is president. In fact, this has absolutely nothing to do with these. So in this case, we have an illustration of how you can have all true premises. All the premises are true, but that doesn't guarantee at all, it doesn't guarantee that you have validity. So now we're going to get on to inductive arguments, and just as deductive arguments had concepts that talked about their adequacy, inductive arguments have concepts that also talk about their adequacy. And to talk about the structure of an inductive argument, we have the concepts of strength and weakness. And this is the cousin to the notion of validity in the case of deductive arguments. But because deductive and inductive arguments are such different things, they're like different games, we don't use the concepts that apply to one game to the other. So for example, you wouldn't say in baseball you scored a touchdown, or that in football you hit a home run. So you have to keep these concepts separate. In the case of inductive arguments, the structure of an argument is characterized by its strength or weakness. A good inductive argument is going to have strength. A bad one is going to have weakness. And the structure of an argument, as we saw in the case of deductive arguments, is something quite separate from whether or not the premises are actually true. And in the case of an inductive argument, where you have a strong argument and all true premises, that's what you would call a cogent argument. So that's an argument where you have strength and all true premises. But let's just focus on the concept of strength for a couple of minutes. What's going on with these diagrams is an illustration of how inductive arguments work. In the case of a strong argument, the premises give you a lot of support for the conclusion. And the conclusion is saying something beyond what the premises say, but the premises give you sufficient support to make the conclusion likely or probable or plausible. In the case of a weak inductive argument, on the other hand, the conclusion is like really, it's going way beyond what the premises state. And for that reason, it's making a much more risky inference, and the premises don't make the conclusion, or fail to make the conclusion, likely or probable. So this is a fairly simplistic illustration of strength and weakness, but we can get an appreciation of strength versus a weak or weakness with these arguments here. If we have a sample size of 98% of dogs, and 98% of dogs like to chase cats, and Fido is a dog, then it's only a very small leap that you would need in order to conclude that Fido likes to chase cats. So going back here to the diagram, the premise gives you pretty strong, solid support to let you make an inference to the conclusion. But when we go to the other example, let's say the sample size is now just 18% of dogs. It's only 18% of dogs who like to chase squirrels. That's a pretty small percentage point. And on the basis of that, and Fido being a dog, you're not going to have strong support for the claim that Fido likes to chase squirrels. It's a very big leap, and a big leap means that you're not going to have a strong basis for the conclusion. So going back here, you're actually making a very big leap to draw the conclusion, and when you do that, you're making a very risky inference. The premises don't support the conclusion with any degree of strength at all. Okay, so we're now on page 7 of our lecture notes, and you'll probably have noticed that I overlooked a chart similar to this when I discussed deductive arguments. I'm going to do that in my next set of lectures for this lecture presentation. In other words, my next set of video recordings for this particular lecture presentation. I'm just going to point out that, as with deductive argument forms, there are some common inductive argument forms, and they all have names, and I'd like you to be familiar with those names. And one of the most common inductive argument forms is what's called an inductive generalization. And a lot of scientific generalizations are made on the basis of this kind of reasoning. So this illustration basically is how we can come up with a universal claim, namely that all metals are malleable, on the basis of observing certain metals, like copper, aluminum, iron, gold, silver, etc., where it turns out each of them is a metal and each of them is malleable, giving us the a good piece of evidence that the generalization, all metals are malleable, is fairly reliable. On the next page, we have another kind of inductive argument form, and that's prediction. And we make predictions all the time. So, for example, we'll say things like, for the past 25 years, it's been very hot and dry in LA. And then on the basis of that, we'll make a prediction in summer 2015 or summer 2016, LA is going to be hot during the summer. And notice that these are inductive arguments because they at best give you probable support for the conclusion. The conclusion is trying to give you more knowledge or information on the basis of the premises, but the premises certainly don't logically guarantee it. Another kind of inductive argument is what's called an argument from analogy, and it's where we make a comparison between two things, and we notice that these two things have certain things in common. And one of those things that we're looking at has a certain feature. And on the basis of these two things having these commonalities, we are given some support, some evidence for thinking that the other thing also has the very same feature. So, prediction, inductive generalization, argument from analogy, these are all common instances of an inductive argument form. And finally, we're going to move on to causal arguments. And again, this is another fairly common type of inductive reasoning. And this illustration uses one and the same generalization, namely eating lots of candy can cause cavities. And in the first example, we say that Kevin ate a lot of candy. Eating a lot of candy causes cavities. So eating a lot of candy would be the cause. Getting cavities would be the effect. If the cause has been determined and you have this generalization, you can, on the basis of that, infer that the effect will occur. But you can also argue in the other direction. On the basis of having a certain effect, in other words, getting cavities, and with the same generalization, eating a lot of candy causes cavities, you can infer the cause. And again, this is an illustration of an inductive argument because the premises don't logically guarantee the conclusion. At best, they support it with a degree of plausibility. So for the next set of video, or for the next video presentation, I'm going to go over the charts that go over all the possible ways in which you can have a deductive argument that's valid or invalid with true or false premises. I'm going to do the same thing with inductive arguments. And I'm going to go over some other things that I left out in this set of lecture notes, or in this lecture video presentation. And I'm going to conclude this presentation with basically a note of admission that I covered a lot of material that's fairly technical, fairly quickly, and it's going to take a lot of time for all of that to sink in. So you're going to have to read the lecture notes and the book several times in this case, because this set of lecture notes is probably among the more technical and complicated compared with the other chapters. So I will post the next video presentation on the remaining parts of this lecture on Monday evening.